Let's look at this function.
Yeah,
a little
all
more
right.
complicated.
Ooh.
Show me with your body, everybody out there. What would this cubic look like?
Well,
Yes, you guys can't see
kinda-
this, but Danielle and Mr. Haas are going, well, Danielle did this and Mr. Haas did something weird like that. Okay, yeah, all right. So, let's find its inverse, okay? And I've been using g of x, but inverse, of course, is this really unfortunate notation. We use f to the -1 to stand for inverse. Just, I always have to remind us that's not a negative exponent, right? It's just bad notation. So since I don't like that, I'm just going to say, let's let g of x stand for the inverse, okay? All right, so last time I'm just going to rewrite this with x's and y's. So here's our original f function. So we talked about the inverse, the x and the y swap, right? The domain becomes the range becomes the domain. So I'm just going to do that here. And then, wait a minute. Last time we solved for y. That's not going to be so easy here to get y by itself. But fear not. I don't need to solve for y to take the derivative, do I? How can I take the derivative of something weird like this? Yes, implicit differentiation. I'm going to take the derivative of each piece with respect to x. All right? We can do that. Derivative of x is 1. Derivative of 4y cubed is 12y squared, chain rule, times the derivative of y. Minus the derivative of 2y is 2 times the derivative of y, which is dy dx. Okay, well, I'm looking for the derivative that's represented by dy dx, so I'm going to factor out dy dx. You still have me there, Mr.
Yeah, still got you.
Okay. Will you have room if I put it all the way down here?
I think so.
Okay. So dy dx ends up being 1 divided by 12y squared minus 2. This is good workout here. All right, so this doesn't look too bad, right? So there's my derivative. It's a little funny that's in terms of y, right? So let's see how that plays out if I ask for a specific value, okay? Let's say that I wanted you to find g prime of -2, okay? So I want you to find the derivative, and keep in mind, this is all in g land, right? This is the derivative of my g function. I want to find the actual value of the derivative when x is -2, all right? Oh, when x is -2. Well, there's no x there. So somehow I have to figure out what the y value would be when the x is -2. Fear not. I can use my original function to figure that out. So, remember when we were talking about inverses, the x becomes the y and the y becomes the x? If this x is -2, then that means the f of x would be -2. So if I can find the x that produces an f of x of -2, that will be the g of x when x is -2. Whoa, that's confusing. Are you guys kind of following this? In other words, if I can find this ordered pair, I can just swap them to get that ordered pair, and then I'd have a value to plug in for my y. All right, let's see if we can do that. I'm going to do some erasing.
Okay.
All right, so I'm just going to do this, because we're good up to here. So now I want to say to myself, what produces an f of x of -2? In other words, what x value would produce a -2? This doesn't look like it would be nice algebraically. We could stick that into our graphing calculator, right? do y1 equals 4x cubed minus 2x, y2 equals negative 2, and see where they intersect, right?
Mhm.
But I think we could probably just figure this out using our head. What x value, if I have 4 times x cubed minus 2 times x, and I'm getting a negative 2? Let's see, if this is a negative 4 and that's a positive 2, that's going to work. Wouldn't x equal negative 1 work? I just kind of did that in my head, but you guys out there could do it in your graphing calculator. Is that going to work?
Yeah.
So in other words, when x is negative 1, my f of x is negative 2. Well, that means when x is negative 2, my g of x is going to be?
Negative 1.
Negative 1. And now I have the y value that I needed to plug in. So I'm going to bring this up here. So the dy dx, when x is negative 2, is going to be 12 times that y value, which is negative 1 squared minus 2, which is 1/10. So g of negative 2 would equal 1/10. Kind of tricky. There is, I think, an easier way to do this. So we'll get to that next.